Hello, Algebra 2 students. Hey, Mr. Rising here. And before we really dive into quadratic functions and whatnot, we should do some review about linear functions. And this is a three-part lecture of linear functions. I'm just going to break it down into little chunks. Feel free to pause, rewind, play again, speed it up. It's your chance to put my lecture where you want it. All right, so lines in a plane, linear functions, lines in a plane, not snakes on a plane. Okay, linear function. First of all, function means for every x coordinate, you have exactly one y coordinate. So that's the definition of a function, period, of one-to-one relationship of input to output. A linear function has a slope, has a variable of x to the first degree. All right, so let's just take a look, and hopefully this is all review. The key to a linear function, of course, is the fact that it has slope. So slope, denoted by the letter m, is the rise over the run, which can either be y2 minus y1 over x2 minus x1, or vice versa, so long as you're consistent about the points. The key there is being consistent. So whether you choose the point on the left to go first or the right to go first, it doesn't really matter so long as you do it consistently throughout the problem. Typically I do y2 minus y1, and really what we're saying here is this triangle is the Greek letter delta, which is used for change. So the change in y over the change in x. And you can see in this problem here, the change in y is the vertical change. So how far are we going down? Well, 1, 2, 3, 4, 5, 6. So 6 down, and we're going, it looks like 9 across. So this would be negative 6. Let me just write this in. Why not? Negative 6 is the change in the y. The change in x is 9. And we're going to write these in most simplified terms. This would be negative 2 over 3. And that is the slope of that one. Hi, Ms. Brazier. All right, picking up where we left off here. Example 1, find the slope of a line that passes through these 2 points. So we've got 1 point, 9, negative 3, and another point, negative 2, 4. I generally like to think of my points, the one point on furthest to the left, having the lowest x value is 0.1, and the other point to the right is 0.2. But again, it doesn't really matter so long as you're consistent, because this point has an x and a y, this point has an x and a y. So given that we've labeled it this way, y2 minus y1 over x2 minus x1. So this is 4 minus a negative 3, which is the same as 4 plus 3, and that's 7. And then negative 2 minus 9, meaning 9 more units to the left, is negative 11. We're going to simplify that as negative 7 over 11. Don't be surprised if you have very unusual fractions, especially in Algebra 2 for slope. As we get into real-life problems, you're going to have slopes with high degrees of decimal, and those are better models of reality than those nice, even, perfect integer slopes that we had in Algebra 1. All right, so what I'd like you to do now is try this problem. Find the slope of a line that passes through these 2 points. Again, watch the negative signs, and remember, subtraction means add the opposite. Good, try this problem, pause the video, and come back and look at the solution. All right, you're back, you've tried it. Let's see what I came up with. So y2 minus y1, I chose these as my 0.1 and 0.2. I've got 7 minus 4 is 3. Negative 2 minus a negative 6 is negative 2 plus 6 is 4. So you should got a slope of 3/4. Now, really important here to just review these concepts, because when the slope is greater than 0, right, you've got a positive slope. The rate of change is constant in an upward direction. As you increase your input, your output goes up. When your slope is less than 0, you have a negative slope, so as you increase your input, your output goes down. A horizontal slope means a horizontal line has a slope of 0, which means you have no slope. It doesn't matter how much you increased your input, the output doesn't change. and this is all function language. We're going to spend a lot of time in Functionville. But when you have a vertical line, the slope is undefined. So think about this too. I'm just going to write this down. An example of an equation that has a slope of 0 would be y equals, in this case, -1. So it doesn't matter. There's no place to put an x input because the slope is 0. The way you can think of that is y equals 0x minus 1. So whatever input you put into this x value right here, you're going to multiply it by 0. It's going to cancel it out, and you're just going to be left with a -1. Now, when you have a vertical line or an undefined slope, it's like having a 0 next to the y. And that can really mess us up, okay? Because for whatever input we put in, we're only going to get the same output. And so that equation looks a lot more like this. X equals. So again, it doesn't matter what input we put in here, we're always going to get the same answer. In this case, this looks like a -1.5 or -3/2. So again, positive slope is upward, negative slope is downward, horizontal slope is 0, and vertical slope is undefined. Now, a big challenge throughout the rest of your mathematical careers is finding equations or functions. And the reason that is so important is if you can model real-life situations, people want to hire you, okay? And we want to start real basic here. We're going to start with linear functions, linear equations. And you will recall this type of linear equation, this form is called point-slope form, which is to say y minus y1 equals mx minus x1, where y and x are input here and output, and y1 and x1 are actual points. M is the slope, x1, y1 is a point on the line. So let's go ahead and try this. Find the equation of a line with a slope of 6 that passes through the point -4, 8. All right, well, I already give you the slope is 6, and I've got -4, 8. And that works pretty good. Okay, well, now what? What does this mean? Well, here's my point slope form. Let's go through it step by step. You hold this form, so y minus 8 equals 6 times the quantity x minus a -4. Of course, x minus -4 is the same as x plus 4, right? And then to solve this, to find the equation, let's take it a step further. Let's distribute that 6 if we want. Add 8 to both sides. And now you're back in a standard function form where your output is here as y and your input is isolated over here as x. So y equals 6x plus 32. Your turn. Find the equation of a line, and here's your great hint. First, find the slope. Go ahead, pause this video, please. Try the problem, see if you can come up with the equation of the line. All right, welcome back. First, finding the slope. Let's scroll down here. Slope formula. And I put the slope formula here and the point slope form over here. Now you can also count the spaces when you have a graph. It works very easily just to look at it and figure out where you are. But let's go ahead here and take a look at what I did. All right, so my slope, I figured the change in y is 8, the change in x is 7. This is a positive slope. And then I take this slope here and plug it into this form. Now, at some point you could say, hey, I'm done right here. Mr. Rising, I have this in point slope form. What more do you want? Well, if I said put it in standard form or put it in slope intercept form, then you would want to isolate the y all by itself and take it from there. So now that I've plugged in my slope, I also need to plug in a point. Now, you can plug in either point. You can plug in this point 0, 2, or you can plug in this point 7, 10. It doesn't matter because you're going to get the exact same answer. I chose the point 0, 2, so when I plug that in and simplify it, I know that's some beautiful handwriting. Thank you, thank you. Y equals 8 over 7x plus 2. Now, here's where the rubber hits the road. Application. The net sales for a car manufacturer were $14.61 billion in 2009 and $17.78 billion in 2013. Write a linear equation that gives the net sales y in terms of x, where x is the number of years since 2000. Then use the equation to predict sales for 2014. So over here, I like to first of all just graph whatever I'm trying to do. So I made a little graph over here. I said, okay, since x is the number of years since 2000, well, 2009 is 9 years from 2000, and 2013 is 13 years. And then I plugged in the sales volume, so this is my y over here. I'll use blue, so this is y. Of course, that's sales, right? And this is years, x equals years. But really what you need to do here is word problems are more like real life, and you need to stop for a moment and figure out what you need to do. So here are my steps that I think you should consider incorporating into your problem solving. What are they asking you for? Number one, what are they asking for? 2, devise a plan to how you're going to find it. And then 3, carry it out. So step 1, what are they asking you for? Let me pull out a highlighter because they're asking for 2 things here. First thing they're asking for is write a linear equation that gives the net sales y in terms of x. Okay? And 2, they're saying predict sales for 2014. What I'd like you to do right now is devise a plan, carry it out, and then come back and check in with me. So go ahead, pause the video. All right, you've tried the problem. Let's take a look at it. So my plan here is the following. First of all, I know it's linear. I'm going to determine the slope, and I'm going to build a function, right? Since I've got slope and 2 points, I'm going to use point slope. So here we go. I'm saying 17.78 less than 14.61 is 3.17, and 13 minus 9 is 4. So that is my slope, and I'm going to simplify it down here as just a decimal. Now I need to come up with an equation. Again, I'm going to use my point slope form. And so 3.17 divided by 4 is 0.7925. And so I'm using that as my slope. I'm plugging in this further point, this 2013 point in. And then it's just a little bit of algebra. Now you can see my final equation here is y equals 0.7925x plus 7.4775. Great real life problem. And have I completed it? Well, write a linear equation that gives the net sales y? Yes. But then use the equation to predict sales for 2014. I've got a couple more steps here. I need to go back and plug in 14 for the years, right? X is going to be 14 back into this equation, and then simplify it. And my final solution, what would I predict for 2014? 18.5725 billion in sales. At this point, I'm going to cut you off. Take any notes, review things, and look forward to the next lecture.